In this video, we're going to study analytical geometry, which is basically circle geometry, equation of circles, right? So let us look at the equation of a circle. And remember, you need to know all your grade 11 analytical geometry, distance, midpoint, equation of lines, and all these stuff. So let's start with the equation of a circle. Right, so what's the equation of a circle? Basically, we have a circle. Now remember, this circle has a center, right? The center is H and K, and it has a radius R, right? So we write the equation of the circle in this form: x minus h all squared plus y minus k all squared is equal to R squared. Okay. Now this is the equation of the circle with center H and K, and with the radius. Now remember, for the radius, you always have to go and find the square root. So square root of R squared is basically R. And this is called the center radius form. This is called the CR form. Right, so equation of the circle in CR form is given by this. Now remember, H and K is basically a coordinate. When you study analytical geometry, we have to put these in the coordinate plane, rectangular coordinate plane, which is X and Y. Now, let's take an example. So we want to check, we want to sketch the equation of the circle with x squared plus y squared is equal to R squared, right? X squared plus y squared is equal to 9, right? Now, if we want to sketch this is basics, because the center, looking at this original form, the center is 0, 0, and the radius is equal to 3. So what will the equation of the circle look like? So what it will look like is you need to center the center will be at 0, 0. Right? And the radius is 3. And so you get the picture. So this is 0, x-axis, y-axis, and the radius is 3. So negative 3, 3, negative 3, and 3. And you can see that's clearly the center, and that's the radius. From this, remember, you can find the x-intercepts and the y-intercept. If you want to find the x-intercept, you always make x equal to 0. So x-intercept is making y 0. So you're getting x squared is equal to 9. And you can see the x-intercept is equal to plus minus 3. In other words, the square root of 9. What's the y-intercept? You're going to make x 0. So you'll get y squared is equal to 9. And then y is equal to plus minus 3. Right. So I hope that makes sense. Let's look at the second example. X plus 2 all squared plus y minus 1 all squared is equal to 4. So now clearly from here, the center is opposite sign, negative 2, and the center is opposite sign, 1, and the radius is equal to 2, right? So center. Now, if I look at the sketch for this, right, we don't need a sketch like that. Let's draw the circle first, right? So the center is negative 2 and 1. And the radius is basically 2. So if you go horizontally from here to there, that point will become, see, that's a radius. If you go horizontally from here, that point will become 3. If you go horizontally from here, it will become -5. See, on the horizontal line. Remember, the horizontal line is very important. You see, that's a diameter. So you're going 3 in this direction. Sorry, you're going 2 in that direction and 2 in this direction. So this point will become 3 and 1. This point will become, it's important that you know the end points on the circle as well. That point will become -4 and 1. Now, if you go up, you're changing the y values. I didn't put the axes as yet, all right? If you go up, you're going 2 up, so that's going to become 0 and 1. No, sorry, not 0 and 1. -2, and the x value remains unchanged, and the y value changes. The y value will become 3. And if you come down, x value remains unchanged, and the y value becomes -1. Those are the coordinates. Also, very important is if they put a tangent on the circle, right? If they put a tangent anywhere along this point, remember the tangent to the circle is always perpendicular. And this is very important because L1, and if this is line 2, the second line, obviously you can find the equation of this line and that line, or the tangent can be anywhere along the circle's path. It can be anywhere on the circle. So just remember the radius is perpendicular to tangent. So L1 is perpendicular to L2. Radius will be perpendicular to tangent. Okay, so that's important. Remember, we're also mixing the circle geometry with the analytical geometry. Now, what happens in a scenario where we have something like this? What if the full, this is the equation of the circle in center radius form. What's the equation of the full circle? So what's the equation of a circle? What's the standard form? Standard form. So the standard form of the equation of the circle is, let's check, ax squared plus bx plus ax squared plus bx plus cy squared plus dy plus e is equal to 0. All right, so there are 5 different variables here. Most of the time, the values of a and c is 1, not necessarily. So let's take an example, number 3, right? This is a standard form. So I have x squared minus 6x plus y squared plus 4y plus 3 is equal to 0. Okay. Now, what do we do in this case? How do we find the center and how do we find the radius? Okay. To find the center, we got to complete the square. You don't have to write is ax squared plus by squared plus cx plus, yeah, it can be in any form. It doesn't have to be like that. It can also be the form is just different variables, all right? So if I put it in polynomial order, it's going to become ax squared plus by squared plus cx plus dy plus e is equal to 0. So I think this is a more appropriate form than this. Let me take this out. It doesn't matter. Sometimes they put in this form, sometimes they put in this form. They tell you to find the values of A, B, C, D, and E, right? Now, sorry, not they tell you to find the values of A, B, C, D, and E. They tell you to find the center and the radius. So we have this equation. Let's find the center and the radius. This is how we go about doing it. We got to complete the square, right? So this is, you group all the x's and you group all the y's, and the numbers, you take it over to the other side. So watch what I'm doing. So you say x squared minus x squared minus 6x plus something squared, right? Plus y squared plus 4y plus something squared is equal to, take this 3 over, you get -3. Because you added two somethings here you need to add on to the other side. Now, what is that something squared? Remember, I said complete the square. So you need to complete the square for x and complete the square for y. So to complete the square for x, you need to take the coefficient of x and divide it by 2 and put it in the bracket. So you're putting minus 6 divided by 2. You need to take the coefficient of y, right, and divide it by 2. So you get 4 divided by 2. You're going to do the same on the other side. Okay? Now, great. We have something here. So automatically this here will become a perfect square. How? X plus y, and that side is just a value. Now, what is the value that you need to put here? Whatever the value is inside the bracket, you need to take this -6 and divide it by 2 with the sign. You can see I took the sign. So that value goes there, which is -3, right? And 4 divided by 2 is 2. So plus 2 here. And on the other side is -3 plus that's -3 squared, which is 9, plus 2 squared, which is 4. Right, so I'm getting over here, which is 10, right? And this is x minus 3 all squared plus y minus 2, y plus 2 all squared is equal to 10. So clearly the center is 3 and -2, and the radius is equal to the square root of 10. Okay, so the center is 3 and -2, and the radius is equal to square root of 10. Any questions, guys? Right, we'll do one more example, right? Uh, right, that's what I have. Now, let's complete the square for this. Completing the square, we need to group the x's and group the y's, right? So x squared plus 3x goes together, x squared plus 3x. Now, by the way, you were going to ask, you're supposed to ask me how to complete the square here. So let me just show you where the completing the square part is. Why it is a perfect square is because you have completed the squares. As a result, you are going to get a perfect square. So you try to expand this. That's why we skip the steps. We try to skip the step because there's no need, right? If you're going to open this up and then refactorize, no use. You already know the value here. So if you're refactorize, you're going to say x squared minus 6x, that is plus 9. That's a perfect square. That's why it becomes like this. Plus, look at the second part, right? The second part is also a perfect square. Y squared minus plus 4y plus 4. That's also a perfect square. If you square this binomial, you will get that. And that's equals to -3 plus 9 plus 4. That's the reason why we skip this step over here. No need to write the step here, right? And even this part over here, you can just use a calculator and get 10. You don't need to expand like this. Right, so I hope you guys are understanding. All right, let's continue here. X squared plus 3x. I'm going to add something squared here. Plus, we have y squared minus 5y plus something squared. I'm going to take this quarter over, so I will get quarter. And this is the fastest way of doing it, right? You can just use a calculator on the other side and solve everything. Plus something squared plus another something squared. Now, what's the value here? We need to take 3 and we need to divide by 2. We need to take -5 and divide by 2, right? And this one is the same. Take the 3, divide by 2 and -5, and we're going to divide by 2. Let's continue. So this will become perfect square. X plus the value of 3 over 2 is just 3 over 2. And over here, same thing. Value of minus 5 over 2 is just minus 5 over 2. Can't be simplified. It is a rational, which is equals to, you can take quarter plus 9 over 4 plus 25 over 4. So I think you will get 35 over 4. 36 over 4 would have been nice because then it would have worked out to a perfect square. Anyways, it's fine. Uh, so now from here, we can get the center. So the center is negative 3 over 2 and 5 over 2. Remember to take opposite sign. See, I took an opposite sign from here, right? I took the opposite sign from here, which is equal, and the radius is equal to square root of 35 over square root of 4 is 2, right? You can write this in decimal form. I hope you guys understood that, right? So it's not so bad. Now, just quick recap of grade 11 geometry, because remember this part here, grade 11 analytical geometry, because this part here will be mixed up with your analytical geometry, where you need to learn about the lines and stuff. So recap of grade 11. Analytical. Right, so we have parallel lines. Line L1 and line L2. So if L1 is parallel to L2, this implies the gradients are equal. M1 equals M2. There's basically equal gradients. Equal gradients or equal slopes. Right. Next, I'm going to do all the recap, right? Perpendicular lines. So we have L1, L2. So L1 is perpendicular to L2. This implies the product of the gradients must be equal to -1. Right, easy. 3. Don't forget about inclination angles. So we got L1, we have a line, right? So we can see y is equal to mx plus c. That's the equation of this line. And we can see the gradient is positive. If the gradient is positive, it's positive sloping, it's an increasing function. The angle theta, which is here, will always be, angle theta will be acute. Now, theta acute means it is between 0 to 90. Right. Theta acute means is between 0 to 90. And the formula that we use to calculate theta is tan theta is equal to the gradient. You must know that, because if the angle theta is given, you will be able to find the gradient. What happens? What's the second scenario? Second scenario is if angle theta is something like this, right? I'm just going to put it on to the other side. Remember, angle theta is always an inclination angle starting from the x-axis touching the line. So this is decreasing. So if gradient is less than 0, it means it's a decreasing function. Theta will always be obtuse. Theta is obtuse, right? And if theta is obtuse, it means that is between 90, and 180 degrees. And we still use the same formula. Tan theta is equal to m. Part D. We came across something very important, something called perpendicular bisector. Bisector. What's a perpendicular bisector? So I have a point 2 and 3. Just say if this point here, point P is basically 2 and 3, right? You have a point 2 and 3, yeah. And this line is given, L1. So the perpendicular bisector will be L perpendicular. So to find the, let's just say this line over here, L1 has this equation. Y is equal to x plus 1, right? Y is equal to x plus 1. Let's see if we can make it something better, like y is equal to half x plus 2. Just say the equation of line L1 is half x plus 2. And if we want to go and find the equation of the perpendicular bisector, to find the equation of the perpendicular bisector, sometimes the endpoints are given, all right? Then you need to find the midpoint first. So to find the perpendicular bisector, it means that there was an endpoint here. This line goes through the midpoint P and it is perpendicular. So the midpoint is already given here. So the midpoint is, remember, the midpoint is given as 2 and 3. Perpendicular bisector means it cuts it exactly in half. So we need to find the midpoint first. Just say if the endpoints were given, we need to find the midpoint. And we can find the gradient of this line, flip the gradient, and then we have a point. And so midpoint is 2 and 3. And the gradient, the perpendicular gradient is basically equals to, you flip this with the opposite sign, so minus 2. So the equation of this line will be y minus y1 equals m perpendicular into x minus x1. We need to take the gradient which is perpendicular to this. So we basically find the equation of line L2 here. So let's say this is line L2. So now we can say y minus, what's y1? 3. What's the perpendicular? Negative 2. Because remember, half times negative 2 is negative 1. We just did that above. X minus 2. So we're getting y is equal to negative 2x. Open this up. Plus 4. And add the 3. You get plus 3. So y is equal to negative 2x plus 7. And this is the equation of the line L2, which is the perpendicular bisector of line L1. So first, midpoint perpendicular bisector means midpoint means two things. You need the midpoint and you need the perpendicular gradient. Gradient which is perpendicular to line L1. And I think that's it. These are like the key concepts. And yes, I was talking about uh, the circles now because we are doing circles, analytical geometry circles. Number 5, let's call this number 5. Right, number 6. Now, what do we do for circles? Remember, they will be given a point, right? You have a center point and you have another point on the radius. right? So you have a point at the center and you have another point on the radius. And now you are required to find the equation of this tangent line here. What is this? This is a tangent line. And that's your radius and that's the center. Okay, I'm going to give you some points, but let's see. If the center is -1 and 2, and that point on the radius, just 1 second. Yeah, and if that point is 4 and 6, right? How are we going to find the equation of the tangent line? So this is what we do. First, we find the gradient of, let's see, this is a point of contact, so P. Find the gradient of CP, which is equals to y2 minus y1 over x2 minus x1. What's y2? 6 minus 2 divided by x2, which is 4, minus 1, which is plus 1. So what are we getting here? We are getting 4 over 5. That's the gradient of CP. Now, the gradient of the tangent, you're going to say the gradient of the tangent is minus 5 over 4. Why? Because radius is perpendicular to tangent. Very important concept. So you need to put that 90 there. Okay. Now, let's solve this. So it's the y minus y1 equals m into x minus x1. Now remember at P, we got a point of contact, which is 4 and 6. Remember, this was a question with all this information. Now, y minus y1, what's y1? Y1 is, you have to take the point of contact here, which is 6. And this is minus 5 over 4 into x minus 4. You're going to open up all this and write the equation in standard form. So minus 6 moves over, it becomes plus 6, minus 5 over 4x, right? Minus 5 over 4 times minus 4 is 4 and 4 cancels out. We're getting plus 5. So y is equal to negative 5 over 4x plus 11. Right, guys? Hope you guys are understanding all this. Right, so remember, take note that this is very important. Also, sometimes the diameter is given and the endpoints of the diameters are given. You need to find the center. So that's easy, right? Just applying basic circle geometry. Let's look at some questions from past papers, right? So let's look at past paper questions. So I'm only working with circles, all right? So I'm just doing the Western Cape paper here. Let's have a look at this question here. In the diagram, this is Western Cape trial 2025, last year's paper. In the diagram, a circle with center O passes through the point A. So see how nice this is, because they're telling us circle center O. If circle is centered at O, then it's just x squared plus y squared is equal to r squared. All we need to find is the radius, and we have the equation of the circle, right? Now let's see. Circle center O passes through the point A. The tangent to the circle at E. E is the tangent to the circle, right? They told us that already. Cuts the x and y axis at C and B respectively. OBC is theta. Theta angle is here. OBC. This is the theta angle in between here, right? And that's quite easy to find. After we find that angle there, we can take vertically opposite and so on, or we can even use. So question number one, determine the equation of the circle. Anyone knows how to find the equation of the circle? Remember, we need the radius, correct? To find the equation of the circle, we said it is x squared plus y squared is equal to r squared. All we need is the radius. So let's draw a radius here because there's only one point that's given. Okay. Now, question is, can we go and find the radius? Yes, we can find the radius by using the distance formula. Okay. So what is the distance formula? We should say r is equal to, not d equals, because they think that it's the diameter. So we're basically solving the first one. So r is equal to square root of what it is, x2 minus x1 squared plus y2 minus y1 squared. Now, where are the 2 points on the radius? The 2 points on the radius is, we got 0, 0, one coordinate, and we have another coordinate, which is 4 and -1. Right, so that's quite simple because we're going to take 4 minus 0 squared, so which is just 4 minus 0 squared, plus you don't need to write the 0, and then -1 minus 0 squared, so -1 minus 0 squared. So it's just basically square root of 16 plus 1, square root of 17. Remember what the equation of the circle is. X squared plus y squared is equal to r squared. So x squared plus y squared is equal to r squared is square root of 17 squared, which is 17. And that's the center radius form. I hope you guys understood that. Does that make sense, Mishka? You good? Arnav, we good?
Yes, sir.
All right, excellent, guys. All right, excellent. O is the midpoint of AE. Yeah, O is the midpoint of AE. If O is the midpoint of AE, it means that they are on the same line, right? So I'm just going to extend this line here, there. So if O is a midpoint of, that's a midpoint, in other words, this is the endpoint. So we can find the coordinates of A, isn't? How can we find the coordinates of A? Very simple. Let me just give you a picture of what's happening here. That's O is a midpoint, so that is 0, 0. And this is A, and this is, call it x1, y1, right? And this is x2, y2, E, x2, y2, right? And O is a midpoint, then those two are equal. So we're solving 4.2. Now, how do we solve for x1? Sorry, we got x2, y2, which is given already, which is 4 and -1, right? 4 and -1 is already given. So let's solve here. We want to solve for x1, y1. So x1 plus 4 divided by 2 is equal to 0. So x1 is equal to -4 because 2 times 0 is 0. So straightforward. Then the next one you will find, you'll say y1 minus 1 is equal, divided by 2 is equal to 0 because we're finding the midpoint. Y is equal to 0 because that's the second y value, right? The first y value was 0 there. The second y value is 0 there. 0 as well. So y1 is equal to 1. So therefore, the coordinates of A is just -4 and 1. Right? And we can fill it in there. That's -4 and 1. Next question. Determine the equation of BC. The equation of BC in the form y equals mx plus c. Now, let's take this information that we have so far on our diagram, and see what they want. See what they want here. They want us to find the equation of BC. To find the equation of BC, okay, so you know the equation of BC is y is equal to mx plus c, or y minus y1 is equal to m into x minus x1. And guess what? We already have a coordinate, we already have a point of contact for BC. So we are going to use coordinate E as a point. Use this equation is faster, right? 4 and -1. Now, the only problem is the gradient, right? What is the gradient? As we said before, we have a radius and we have a tangent. Remember this concept. Radius is always perpendicular to the tangent. So what's the gradient of the radius? The gradient of the radius is 0 minus 1, or -1 minus 0 over 4 minus 0. Y2 minus y1 over x2 minus x1, which is -1/4. So what's the gradient of the tangent? The gradient of the tangent is 4 because radius is perpendicular to tangent. And now problem solved, because that's 90, radius perpendicular to tangent. We have coordinate E, we have the gradient. We can solve this equation. So y minus, what's y1? y1 is -1 equals m, which is 4, into x minus x1, which is 4. So this is +1 moves over, becomes -1. 4 times x is 4x. 4 times -4 is -16. Y is equal to 4x minus 17. So the equation of this line is 4x minus 17. So now this is nice because this coordinates of B is a y-intercept of the tangent. So this is 0 and -17, isn't it? Because if x is 0, you can find the y-intercept. We can clearly see the equation of the tangent is 4x minus 17. So 17 where? It's right here. Okay? So that's nice. Nice question. Let's move on to the next part. So I want all this information here, because remember, as you fill in information, we need to continue with this. You can't miss this diagram. So far, we have this diagram here. Now let's work with this diagram and answer this question. Determine the equation of the line BC. Determine the equation of the line through the center of the circle that is parallel to tangent BC. Very simple. That's what we want. It must be parallel to BC, but this line here must pass through the center of the circle. So if this line passes through the center of the circle, obviously it passes through the point 0, 0. So we have a point O, 0, 0, where this line passes through. And the gradient through 0 is equal to the gradient of the tangent, because parallel lines. And what was the gradient of the tangent? 4. So it's easy. Y minus 0 equals 4 into x minus 0. So y is equal to 4x. Determine the equation of the line through the center of the circle that is parallel to the tangent BC. Okay? So y is equal to 4x. That's it. Ooh, next question is 7 marks. Think about this now. A circle with center S, AB, touches the circle with center O externally at E. Let me draw another diagram. The circle with center S touches the circle with center O externally at E. BC is a tangent to both circles. If OS is equal to 3 times OE, determine the coordinates of S. So they're talking about this circle over here, right? But what's happening with this equation of the circle? What is OS? OS. Okay, this is another center, right? S is AB. OS is equal to 3 times OE. Yeah. So what they're saying is that this is a bigger circle over here. Right? OS, where's OS? OS is from there to there. The length is from the center of the small circle to that point, right? Oh, you can use ratios for here. You can say OS over OE is 3 is to 1. That's what it means, right? OS to OE is 3 is to 1. OE is X, in other words. The distance is R, then that must be 2R. Okay, guys? R and 2R. We need to find the coordinates of S. What was the radius? What was the radius of, what was R? R was equal to square root of 17, right? And R was equal to the square root of 17. So we have 2R here. Equation of this, equation of the circles. What's the best way of solving this? R is equal to the square root of 17. Determine the coordinate of S. Should we use angle theta here? Why did they give us angle theta? Okay, what we can do is we can create two equations and two unknowns and solve that rather. So watch here. That's what I'm going to try to do. This is a tangent. BC is a tangent to the circle. Okay. They told us that BC is a tangent to this, both the circles, all right? So what is the gradient of BC? Gradient of BC was -4, right? So the gradient, remember this is 2R, and we already have the gradient. We can also get the gradient of this line. It's the same 9, by the way. Gradient of BC is -4, so the gradient of ES will be equal to a quarter. Was it a quarter? Sorry, not -4, it was 4. And this is -quarter. Where's -quarter? Yeah, we found -quarter there. It will be the same gradient, -quarter. But how are we going to use this -quarter? We need to say, we know that the answer is -quarter, so that is -quarter, but it is b minus -1, b plus 1. divided by, it is b plus 1 divided by a. You understand how we got b plus 1? Because we're trying to find the gradient of ES. ES gradient is b minus minus 1, y2 minus y1 over a minus 4. Right, and that is equal to, negative quarter. Yes, because it's on the same line. Now, if you cross multiply, try to write b in terms of a or a in terms of b. A minus 4 times negative 1. Okay, 4 into b plus 1 is equal to, I think, put that b plus 1 on the other side will be better, right? So let's take a minus 4 times 1 plus a minus 4. And I'm going to keep that negative 4 here, multiplied across negative 4 into b plus 1. So I've created one equation. Remember, there's two unknowns, a and b. So a is equal to minus 4b, that is minus 4 plus 4, that is 0. Okay, so a minus 4. Remember, if I open this up, this is a minus 4 minus 4b minus 4. Minus 4 can cancel out, so a is just equals to negative 4b. All right, so this is equation 1. Nice. I've created equation 1. What about equation 2? I would use the distance formula for 2r, right? I will use the distance formula. If I want to calculate ES, remember r is root 17. What is 2r? 2r is equal to 2 root 34. So I need that part in here. So let's write it out. Yeah. So we're going to say ES, distance ES is basically equals to distance ES is basically equals to square root a minus 4 all squared. I'm finding ES. So x2 minus x1 all squared plus y2 minus y1 all squared plus b plus 1 all squared. And that distance ES is equal to 2 root 34. Okay. So this is a minus 4 all squared. I'm just squaring both sides. A minus 4 all squared plus b plus 1 all squared is equal to, what's 2 root 34 all squared? So 4 times 2 squared is 4. 4 times 34. Right. Now, can someone just tell me what's 4 times 34 on the calculator and get it? Now, remember, this is second equation. This is equation 2. Now I will take equation 1 and substitute into equation 2. So what is A? A is minus 4b. So I'm going to substitute this minus 4b inside here because A is minus 4b. Minus 4b minus 4 all squared plus b plus 1 all squared is equal to, what is that, 68. 136, all right? That's what it is. Yep. Now square this and square this. Do we need to square this? Maybe we can take out negative 4 as a common factor. Now, you can go and open up this entire binomial. That's what you will do. You won't use like tricks to solve this. So we can say 16b squared. Product of these two will give me 16b times 2, 32b. You understand how I got that? Minus 4 times minus 4b is 16b times 2 is 32b plus 16 plus b squared plus 2b plus 1 is equal to 136. 16b squared plus b squared is 17b squared. 32b plus 2b is plus 18b. And 16 minus 136 is minus 120. Whoa. You got 16 plus 1, which is 17. 17, that's minus 120, minus 119. Guys, just check if this works on the calculator quickly. Mishka, you checking? Mode 5, 3. We got 17. We got 18. And we got minus 119. Why are we getting such funny answers? Did the right thing. The distance is a minus 4 all squared plus b plus 1 all squared is equal to 2r. 2r is, whoa, it's not, sorry, it's not 2 root 34, it's 2 root 17. That's why you're getting it off. 2 root 17. Why did I put 34? Supposed to be 17. You can see clearly this distance, the coordinates not coming out right. It's coming out funny answers. So we need to go back and check. So it's 17 here, 4 times 17. So this here should be, yeah, 34, 68 should be 68. 68, 68. Uh-huh. Should work out now. Let's see. 17 minus 68. Mode 1, 17 minus 68. 17 on this side, minus 68. You're getting negative 51. Is equal to 0. Let's check if this works now. Mode 5, 3, 17, 18, and negative 51. Still. Or not? 2 root 17, a minus 4 all squared plus b plus 1 all squared is equal to 2 root 17. What if I went to took the distance from here to there? Okay, what if I don't use the 4 and the negative 1? Why am I getting funny answers? 16b squared plus 32b. Make a mistake here as well. 34b, 34b, 32, 34, mode 5, 3. We're getting 17. I think we can divide this by 3 as well. We can divide this entire thing by 17. Yeah, I think we can divide by 17. So we get an easy equation, b squared plus 2b minus 3 is equal to 0. Yeah, divide by 17. I think it's plus 3 minus 1, right? So b is equal to negative 3 or b is equal to negative 1. So which one should it be? If b is negative 3 or b is negative 1? B is this value. It can't be negative 1 because it's in this line, so not applicable. And if B is negative 3, what's the value of A? A is equal to minus 4 times negative 3. A is equal to 12. So the coordinates of S is therefore 12 and negative 3. That's the thing about 7 marks question, guys. You got to create 2 equations and 2 unknowns and try to solve that. We can see, sorry about these issues in between. I don't know why I multiplied the 17. It's supposed to be 2 root 17 because R is root 17, and we eventually got the answer 12 and negative 3. If you try to substitute here, if you substitute negative 1, then the value will be negative 4 times negative 1. It's going to be 4 and negative 1 as well. Yeah, it's going to be sitting at this point, and that's not the case. So it has to be this 12 and negative 3. Arnav, are we good? Mishka, make sense?
So could you maybe like run through it one more time? Like Please
Okay,
quickly
great.
clarify.
Okay. Okay, so first, they told us the circle with center S touches the circle with center O externally at E. So they touch externally. In other words, they have a common tangent, right? BC is a tangent to both circles. If OS is equal to 3 times OE, we wrote it in ratio form. So this is OE is R, and this is 2R. All right, determine the coordinates of S. So remember what we said, R is square root of 17. So 2R is 2 root 17. So keep that in mind. But before that, remember, because they're telling you to find the coordinates of S, it has two unknowns. So you got to create two equations. So the first equation I will get is by using because OS is on the same line as ES, they must have the same gradient. So remember the gradient of BC was 4. The gradient of ES has to be negative quarter. How I got that? Because the tangent is perpendicular to the radius. This is the radius of the bigger circle, right? So let's calculate the gradient of ES is B minus minus 1, B plus 1 over A minus 4, right? And that's equals to negative quarter. I cross multiplied the gradient part and I've got A equals negative 4B, right? Now the next part is, yeah, I've got negative 4B. Now the next part is taking the distance, right? The distance ES, we already know the distance ES, which is 2 root 17. But now use the distance formula to create an equation. So which is A minus 4 all squared plus B plus 1, y2 minus y1 all squared is equal to 2 root 17. And if you square both sides, 2 squared is 4, root 17 squared is 17. That will give me 68. If you open up all this information, remember what was A? A was negative 4B. And now you're just solving a linear and quadratic simultaneous equation. That's it. You're going to reject negative 1 because negative 1 is going to give me a value of A, which is negative 4 times negative 1, which is 4. But 4 and negative 1 is not the center of this circle, is exactly at E. That's why I reject this. Right? So this is rejected and that's accepted. I was just thinking of, whilst I was doing this problem, I managed to find an alternative solution because I was thinking of maybe using geometry to solve this 7-mark question, right? Let's try to use geometry to try and solve this. Right, now look here. What is the distance from here to there, isn't? Look at that, that is 90, all right? What is the distance from that to this perpendicular line over here? That is 4. And what is the distance from E to that line? That is 1. Are we good? Look at this distance. And then I will do a similar thing over here. Okay? Make sense? I'll do a similar thing over here. And the distance from O to that point over there. Let's call these different points now. You got O, let's call it coordinate A, and let's call it coordinate B. So I've got, no, I can't call it A and B. Let's call it P and Q, right? So point P is here. I dropped a perpendicular on the x-axis. So the from O to P is 4, and from E to P is 1 distance. And similarly, same here. I dropped a perpendicular on the x-axis. Q is from there, from the top to the bottom, which is A. That entire distance is A, right? And B is from here to there. All right. Now remember, they are perpendicular, so this angle P is equal to angle Q, right? And remember this angle over here, so they are parallel as well, right? So that angle, if I put theta here, I shouldn't be putting theta. I can use theta if I want. Let's use beta because theta is already there. And if that angle is beta, this angle is also beta. Now I can find this. I can say tan beta. I can say tan beta is what? Tan of beta is 4 over 1. Tan beta is 4. So angle beta is now equals to tan inverse 4. 75.96. Okay. Now, why am I doing this? Look at this triangle. When I drop the perpendicular here, you can say angle OPE, angle OPE is equal to angle OQS. And they're both 90 degrees. Why? Because I dropped a perpendicular, right? Right, so they're both 90. So if they're both 90, obviously these lines become parallel. I'm trying to use geometry here, geometry and trigonometry to solve this. So this means that PE is parallel to SQ, right? PE is parallel to SQ because corresponding angles equal. Can you see? Angle P and angle Q. You can call it angle P1 and angle Q1 instead of using this 3-point notation. So we're saying tan beta is equal to 4. Beta is equal to 75.96 degrees. Now we are here, right? Now try to find, we have an angle, right? Try to find A and B. How are we going to find A and B? Tan of, we got this angle here, opposite over hypotenuse. Opposite over hypotenuse, opposite over hypotenuse. Can we do that? We have this angle, which is 75.96 degrees. If we have the angle, this is 3R. Oh, yes. Remember the value of R is given. Adjacent of hypotenuse. So what is cos? So we're going to use cos of 75, cos of 75.96 degrees is equal to adjacent, which is B, over the hypotenuse, which is 3R. And remember, R is equal to root 17. So what is this implies? B is now equal to uh, 3 root 17 because 3R times cos 75.96 cos 75.96 degrees. And what's the value for B? 3 root 17 cos. Now you good? You're understanding? That's 3. Okay. But now remember the value for B can't be 3 because it's coming down. So since B is less than 0, it implies the value for B is -3. I just made everything positive. Now, how are we going to find A value? We're going to use sine. So we're going to say sine 75.96 degrees is equal to opposite over hypotenuse. So opposite this is this entire thing, A over 3R. So A is now equal to 3 root 17, R is root 17, sine 75.96 degrees. And A is already positive. So let's change this cos into sine. Which can be good? Understanding? Isn't that trig is much more easier? That's approximately 12. So the coordinates of S is 12 and -3. Okay. Now I use trigonometry and geometry to solve this. Remember, there's another way which is called similar triangle. You can also use similar triangle. You can say triangle OPE is similar to triangle OQS. So there's 3 different solutions for this. Are we good, Arnav? Does that make sense?
Yes, sir.
Obviously, this is much more easier than that solution. This was quite long because we had to use simultaneous equation and stuff. Whilst I was doing this, I said, oh man, why didn't I use trigonometry? Because we had this coordinate, just bring it down to the x-axis. We have the hypotenuse. Everything easy, right? Oh, great. So this is like analytical geometry. You got to think. Let me look at the next paper here. Let's see what they had in analytical geometry. I want to look at circles, all right? This this is the thing that you need to focus on. See, even in circle geometry, what they're doing is they are using, because this is circle analytical geometry, they are trying to use what you call your circle theorems in analytical geometry. Let's have a look at this question. In the diagram below, by the way, this question comes from Northwest Province paper, right? This question is from the Northwest Province paper 2. Now, let's have a look at this question. In the diagram below, the circle with center A has equation. So the center A has equation. Now, if this is the equation of the circle, the big circle, then what's the coordinates of A? Anyone? What's the coordinates of A? Opposite sign, opposite sign. So the coordinate of A is -1, -1, right? And the radius is 3. Write down the coordinates of A, -1, -1. Easy, because straight away from the equation of the circle. So I'm going to write that down as well. That's -1, -1. That's the coordinates of A. Now, FG is a chord to a circle, AD bisects chord FG. Why did they give us this information? They gave us that information, AD bisects FG, because line from center midpoint of chord is perpendicular. You also need to use these theorems. FGC is a tangent. Nice. If this is a tangent, now you see a radius means tangent. Now this line here is a chord to the big circle, but it's a tangent to the small circle. That's also perpendicular there. Radius means tangent at 90. Okay. If they are tangent, then obviously you got 90 there and you got 90 there. Isn't these lines will be parallel? Yeah, it will be parallel because you have corresponding angles equal or co-interior angles equal, whatever you would like to say. Great. Center B, this is a center B, which is 3 and 2, and the C is 4 and 1. So obviously it's possible to find the equation of FC. How? We can find the gradient of BC, the gradient of the radius, and you're going to flip the gradient and get the gradient of this, and you can find the equation of this line as well. So you can find the equation of this line. Great. Once you have the equation of this line, watch what I'm doing. So I got the equation of this line because remember, I'm going to find the gradient of BC, change the gradient because it's perpendicular. I have a point, I can find the equation of this line. Once I find the equation of this line, carry on. I'm going to use the gradient of this line, right? Now, obviously, the gradient of AD and the gradient of BC will be the same because both of them are perpendicular. So I don't know what they're going to ask there. Uh, mm, yeah, I'm not sure what question they can ask. Let's see the build up. Determine the equation of FC. Determine the equation of FC in the form y equals mx plus c. So we just did this now. I was discussing the same thing. So let's answer this question. FC 4.2. What is the gradient of BC? Gradient of BC is y2 minus y1 over x2 minus x1. When I write BC, I take C as my second point. So what's y2 minus y1? 1 minus 2 divided by 4 minus 3. And your gradient must be downsloping, which is negative. So -1. That's a gradient of BC. So the gradient of FC is equal to 1. If you flip this, flip the sign and this fraction, you get 1. Remember, this can be written as 1 over 1. And -1 times 1 is -1. Now you know you need to say BC is perpendicular to, no, radius perpendicular to tangent. Right, so there's not only reasons in Euclidean geometry, there's also reasons in analytical geometry. Because you're dealing with circles, you got to write some circle geometry proofs or reasons, right? So the gradient of FC is 1, and it passes through the point 4 and 1. Okay, this line passes through the point 4 and 1. So y minus y1 is 1, equals m, which is 1 into x minus x1, which is 4. If you open up this entire equation, take this minus 1 over, you get plus 1, and that is just x minus 4. So y is equal to x minus 3. Right, so y is equal to x minus 3. That's the equation of FC. Right, so we have written down the equation of FC. Great. And let's continue answering these questions. So far, I have this information. Please do not lose the information. You need to carry on, continue on to the next question, on to the next question. So it's never an independent question in these cases. So it continues with the same information that you have done prior to this. Given that AD is root 10 over 2, AD, the length of AD is root 10 over 2. Calculate the length of FG. AD is equal to root 10 over 2. Isn't that a distance that's given? AD is equal to square root of 10 over 2. Calculate the length of FG. Is there an easier way of doing this? AD is equal to square root of 10 over 2, but we don't have the coordinates of D. Isn't the point D can be written as X and Y, isn't? But what is the equation of FC? Equation of FC is y is equal to x minus 3, isn't equal to x minus 3. That's what we had. Remember the equation of FC is x minus 3. So this is nice because remember I wrote the coordinates of let D be x and y. But the point x lies on FC. So you just say if the value of x was 2, for an example, just say if the value of x was 2, then what would the y value be? You have to take 2 and substitute into the FC equation because it lies on this. Now I'm saying the value of x is x. So what's the value of y? It is x minus 3. So you can rewrite D as x and x minus 3. That's what D is. So think of D as being x and x minus 3. So that's the build up so far. Now it's easy because you're just finding the distance. What you are finding, the information given. What is AD? How will you go and find AD in general? Not given this information. You will basically use the distance formula. How would I go and find AD? I will find AD by saying AD is equal to the square root of y2 minus y1 all squared plus x2 minus x1 all squared. But now I already have AD, which is root 10 over 2. So I will write root 10 over 2. Now, let's simplify. What is y2? Y2 is this point here. See? This is y2 and this is y1. Right? Yeah, so D and what's A? A is -1 and -1. So let's simplify. Now, what is y2? Y2 is x minus 3. What's y1? Y1 is -1. So I'm done with these two. -1 becomes +1. What is x2? X. And what's x1? -1. So +1. Now I'm going to square this both sides. So now over here I will have x minus 2 all squared plus x plus 1 all squared is equal to, if I square this, I will get 10, and if I square the 2, I will get 4. Right, now 10 over 4 is basically 5 over 2. Now all I need to do is solve this equation. So let's expand this. X squared plus x squared minus 4x, squaring a binomial, plus 4 plus x squared plus 2x plus 1 is equal to 5 over 2. Let me simplify this and then cross multiply. 2x squared minus 4x plus 2x is minus 2x, plus 4 plus 1 is plus 5, is equal to 5 over 2. Now I'm going to cross multiply, take the 2 and multiply by that. So 4x squared, or multiply the entire equation by 2. 4x squared minus 4x plus 10 is equal to 5. Bring the 5 over, make a quadratic, and solve. There might be easier way, but I don't know. I just thought of this. Let me see, just 4 marks. That's a midpoint, but calculate the length of FG. Now, why am I getting this coordinate here? We wanted the length of FG. I'm trying to get the coordinates of D here. Will this work? Mode 5, 3, 4, -4, and 5. No, it's not working out. Unless AD is root 10 over 2. If AD is root 10 over 2, what is this? 1 second, guys. This is the radius. And that's another radius here. That's R, that's R. AD is root 10 over 2. Man, messed up here. Okay. Why was I going to, why did I wanted to calculate the coordinates of D. I was trying to calculate the coordinates of D, but it's not working out. Why? Why is the coordinates of D not working out? Y2 minus Y1. Y2 is x minus 3 plus 1, x plus 1. Everything is fine here. 2x squared plus 4 plus 1 is plus 5. 4x squared minus 4x plus 10. 4x squared minus 4x plus 10 is equal to 5. Take this 5 over, plus 5. 4 minus 4 and 5. Maybe that's not required. Yeah, it wasn't required. But the coordinates should work out. X and Y. Okay, look. After I reached this point and I was finding the coordinates of D, I realized that I'm not finding the coordinates of D. I'm actually finding the length of FG. To find the length of FG, we got AD, all right? We also have AF, right? What is AF? Then we can find FD and then DG. Sorry, guys. Ignore this. Take this out. Yeah, that wasn't required of us to do. They didn't ask us for the coordinates of D. What they asked for was FG. Now to find FG, remember we already got the radius. What is the radius? The radius is, remember the equation of the big circle was given, which is 9, which is 3. The radius is 3. And then we can say AD is perpendicular to FG. Why is AD perpendicular to FG? Because line from center, midpoint of chord, right, Mishka? Line from center midpoint of chord. Well, it's try, you got to try different techniques. Now, let's see. In triangle, I would say in triangle AFD. In triangle AFD, I have Pythagoras. I can find FD. FD is equal to the square root of R squared minus AD squared. Why? Because Pythagoras. I'm using Pythagoras here because I want to solve this. Now, see how easy the solution was, man. I was just going right about. So what's R squared? R squared is 9 because R is 3. That's 9. And what's AD squared? AD is root 10 over 2. So we can just add root 10 over 2 squared. You can put 3 squared here if you want. Nine minus, that's 10 over 4. That will be 5 over 2. Let's just put the whole thing. Square root 9 minus 10 over 4. Square root 26 over 2. Root 26 divided by 2. But now FD is root 26 divided by 2. This implies FG is equal to 2 times root 26 divided by 2, which is just square root of 26. Such an easy solution, man. Right, Arnav? We good? Make sense?
Yeah.
Right, excellent. Good stuff. But it was worth a try. But you can see I was ending up with like non-real solution, complex numbers. Let's continue with the build up here. Next question. Determine the length of AB. Why did they ask for AB? What they asked for? The length of AB. Hey man, that's easy. What's the length of AB? It's just distance between the two centers, isn't AB? AB is equal to the square root of what? AB, so 2 minus minus 1 plus 3 minus minus 1. 3 plus 1 basically. I think you're getting 3 squared plus 4 squared, the square root of 25, which is 5. This is Pythagoras. Is it Pythagoras? No, this is distance formula, not Pythagoras. Okay, so if you solve AB, you will get 5. So the distance from there to there is 5, basically. That distance is 5. That's what it looks like. That's what they're saying. That's 9 plus 16. The square root of 25 is 5, AB. That's an easy question. Now, what are they asking us here now? There's another circle. Another circle with center B touches the circle with center A at K. Determine the equation of the new circle. Wait 1 second. Let's take this diagram and fill in that information that they're giving us. And we have to use everything above that we solved. Don't forget anything. So what are they telling us here is that another circle with center B touches the circle with center A at K. We need to draw another circle, right? Another circle with center B touches the circle with center A at K. So basically they're touching here. You have to draw another circle with the same center. So the center is exactly the same for this circle. And it touches the circle with center A at K. So these two circles are touching at K. Great. Determine the equation of the new circle. Well, we have the center of the circle, right? What is the center? 3 and 2. All we need to go is find the radius. Now remember in the previous example, we went and found from A to B. Isn't we found the distance from A to B? Now I want you to think about this from A to B. What is the distance from A to B? All right. Think of this as a radius 1, small radius from there to there, right? And this is a radius 2. So what is AB? AB is equal to AK plus KB, right? Because they are touching, intersecting circles. What is AK? AK is radius 2. And what is KB? That is radius 1. And what is the total distance? AB. What is AB? AB was 5. We solved in the previous example. Remember, AB, we solved that it was 5. Now, what is radius 2? Radius 2 is already 3. How we know that? From the equation of the circle. See, they told us x plus 1, y plus 1 all squared is equal to 9. So minus 1, the radius is 3 there, right? And the plus R1 is equal to 5. So what's the equation of the new circle, that purple, that blue circle that I drew? Radius 1, the equation of the new circle, radius 1, is basically 5 minus 3, which is 2. Now we got the center and we got the radius. Determine the equation of the new circle. I think they want it in center radius form. So the equation will now be x minus 3 all squared plus y minus 2 all squared is equal to the radius squared, which is 4. Right. I hope you guys are understanding this, right? Make sense? Abhinav, we good?
Yes, sir.
All right, excellent. Very nice questions, guys. That was a nice question. We move on to another paper, analytical. Now they have in this, the equation of the circle appears right here in this. Okay, no, this is a better question. So this is Northern Cape. In the diagram below, a circle centered at M. Circle is centered at M with the equation. Look at the equation of the circle that's given, which means that we need to complete the square to get the center and the radius, so we can get MP. From A is Tn 0, a tangent is drawn to touch the circle at P. This is the tangent, so tangent perpendicular to radius. Triangle APM is drawn and AP is equal to 2 root 10. AP is equal to 2 root 10. Okay. Now, let's see. Give a reason why angle APM is 90. That's easy because radius is perpendicular to tangent. Okay. Radius perpendicular. Calculate the coordinates of M. Now, in order to calculate the coordinates of M, we got to complete the square, right? So 4.2.1. Look at the equation of the circle that's given. Yes. So what we need to do, we need to complete the square. How? So we're going to say x squared minus 4x plus something squared plus y squared plus 10y plus something squared is equal to, take the 19 over, you get negative 19 plus something squared plus something squared. What is that something? Minus 4 divided by 2 here. What is that something? 10 divided by 2 here, minus 4 divided by 2, and 10 divided by 2. Now, that automatically becomes, write the format, and you can do all this on the calculator. That's minus 19. What is it? See here, that's mode 1. Minus 19 plus, what's minus 4 divided by 2? That's minus 2 squared, which is 4, plus 10 divided by 2 is 5. 5 squared is 25. So I'm getting 10, right? This value minus 4 divided by 2 is minus 2. 10 divided by 2 is plus 5, right? So I have the center and I have the radius. The radius will be root 10. So MP is square root of 10. What's the M? M is 2 and negative 5. You can see 2 is on the positive side and it's clearly in the fourth quadrant. So coordinates of M is 2 and negative 5, right? So you have to complete the square here because the equation of the circle was given in standard form. Right, so more question, the length of PM, right? The radius of the circle. So we already found PM. PM is PM is equal to root 10, right? Show that T is equal to negative 3, 4 marks. Right, so how are we going to solve this question? Show that T is equal to negative 3. Ah, I have a way. Look at this triangle. We got root 10 and we got 2 root 10, okay? We got root 10 and 2 root 10. So obviously it's possible to find MA using Pythagoras. Once you find MA, use the distance formula and find AM. Then you can find T. So let's see. What is MA using Pythagoras? AM. AM is equal to the square root of AM is the hypotenuse, all right? AM is equal to the square root of root 10 squared plus AP squared, which is 2 root 10 squared, because I'm using Pythagoras. I have a right angle triangle here. Now, root 10 squared is just 10 plus 4 times 10, that is 40. So square root of 50. Is that right? Square root of 50 is what? 25 times 2, so 5 root 2. Think about it, guys. So I'm going to write down 5 root 2 here. AM is equal to square root of 10 all squared, that is 10. And this is 2 squared is 4. 4 times 10 is 40. And then the square root of 50. 25 times 2, 5 root 2. Yeah, that's fine. That's correct. Now, what is AM? Think about AM and writing it in different form using the distance formula with T0 and 2 and negative 5. So AM is equal to square root of what? 2 T minus 2 all squared plus 0 minus minus 5. So 0 plus 5 all squared, which is equals to 5 root 2. We already know that AM is 5 root 2. Right? Using the distance formula. If I use the distance formula here, then obviously I have T as the unknown, but I already know the answer for AM, which is 5 root 2. Now solve. You square both sides. You get T minus 2 all squared plus 5 squared is just 25 is equal to 25 times, so it's just 50 because you're squaring both sides. I'm getting rid of the square root. Now I'm going to take the 25 over uh, T minus, you can make a quadratic and solve, right? No issues. T squared minus 4T plus 4 plus 25 minus 50 is equal to 0. Now you got T squared minus 4T, multiply all this out. What's this? 29, 25. That's minus 25. You're gonna get plus 20, minus 21, sorry. Yeah, you'll get minus 21. So now you're getting T minus 3, T plus 3, and T minus 7 is equal to 0. So T is equal to negative 3 or T is equal to 7. So not applicable here because the value of T is on that side. So T is equal to 3, negative 3. So we proved it, okay? So the value of T is negative 3. Making sense, Arnav? We good?
Yes,
So
sir.
remember, you got to use distance formula. You can see the ideas that you are picking up. Distance formula, completing the square. You need to use distance formula. You need to use, most of the time I'm using distance formula to create my equations. I'm using distance formula, I'm using Pythagoras. All that is important in circles, analytical. Oh yeah, we had one more question here. Show that T is equal to negative 3. Right, so that's sorted. Next part. I completed, this is a separate question and they're adding another circle to this circle. Now, let's see the information, what they're telling us here. Another circle centered at N. Another circle is centered at N with the equation. Wait, we have to draw it. Another circle centered at N with the equation x minus 5. So the value is 5. So obviously it can't be at M. M was, uh, let's take this rather. Let's take this point. Let's take this circle and let's work with that. The information that we have so far. Let's work with the circle, right? Now they're saying another circle with the equation x minus 5. Now you already know because of the minus 5 here that the x value is 5. So obviously it can't be to the left of M. It has to be to the right of M. So there is another circle which is something like this. Let's draw another circle, right? And where is it? Is drawn center N lies. So this equation of the circle has center N. Is drawn center N lies produced on line MA. MA. Center lies on produce line MA. MA. X value is 5. Center N lies on produce line MA. This line is produce MA. Center N lies there. How? Center N lies on produced line MA, and the equation, and how can it lie on that side when it's x minus 5 all squared? The x value is positive. Write down the coordinates of N. I got a problem here. Another circle center N with equation x minus 5 all squared. I think there might be a problem with this question. Write down the coordinates of N. Center N lies on produced line MA. So is the line produced on this? Okay, so it can't lie there. So the produced line is somewhere around here. Yes. Okay. So it has to lie around there somewhere. Yeah, because remember, the 5 needs to be positive. It can't be on the left. The circle can't be on the left of M. It has to be on the right. So the circle center is somewhere around here. See what they said, produced line MA is, this line is produced here. Okay, so that line is produced there, and center N lies on that produced line. In other words, that line which is extended. And I need to get a center M. And by the way, what is the radius of this circle here? Is 2 root 10, isn't? So it's way bigger than this circle. So this circle is like really big. It's way bigger than that other circle there. Right, so this is N. Now Mn, so basically Mn will be, that's the center. So that will be, what is r squared of this circle? Remember the equation of the circle is given. The coordinates is 5 and something. I don't know what this value is because that value is just E. You can see here, it is 5 and E. So I'm gonna write that center is 5 and E. E is the unknown. All right. But we now know the radius because r squared is 40. If r squared is 40, then we know the radius r squared is equal to 40. Then we know the radius is 2 root 10. Because if you square root both sides, we'll get r is equal to 2 root 10. So the radius from M to N is 2 root 10. Okay. Okay, that's the information I have so far. That's great. Now, MA with equation y is equal to minus x minus 3. Now, this line already has the equation. What is the equation of this line? Y is equal to negative x, negative 3. Right? That's the equation of that line, negative x, negative 3. Write down the coordinates of n. The coordinates of n is easy because I'm just going to take the value of 5 and substitute it into the equation of this line that's given. Right? So n is a coordinate 5 and e. So I'm going to write down y is equal to the equation of MA. Y is equal to, or the equation of Mn is y is equal to negative x, negative 3 at x is equal to 5. If I substitute 5, I will get y is equal to negative 5, negative 3, which is negative 8. So which is the value of E. Therefore, the coordinates of N is 5 and negative 8. Write down the coordinates of N. Good. Determine whether the two circles centered at M and N will intersect, touch externally, or do not intersect at all. Now, how do we check that? Determine whether the two circles centered at M and N will intersect. Now, what's the center of M? I just drew the circle like this, all right? It doesn't mean that it's going to intersect, all right? So I do have two circles. Now we want to check whether if these two circles intersect, all right? So I have a circle here. What's the circle center? The circle center M, and I have another circle here. I don't know whether if they're intersecting or not. I just want to check. And I have a bigger circle here, and which is N. I'm just drawing not intersecting for now. Uh, what's the center of the first circle? The coordinates of M was 2 and -5. And the second circle was 5 and -8. Okay. Now, I want to check the distance from, oh, I want to know what's the radius here. The radius of this first circle. What's the radius 1? And the radius of the big circle, what's the radius 2? And then I can check whether if they intersect or not. Right, so first you add the radius. This is radius 2, right? So what is R1 plus R2? R1 plus R2 is equal to, what's R1? The radius of the small circle, R1 was root 10, isn't it? Because M to P is a radius 1, so that's a root 10. The square root of 10, and the second radius is 2 root 10, right? So that's going to give me 3 root 10. Second radius is what? 2 root 10, and that's root 10. Now, let me try to calculate the distance mn, because I have the centers of both the circles. If the distance from m to n, using the distance formula, is equal to the sum of the radius, then the circles must touch, because remember, radius 1 plus radius 2, there will be no gap in between. So the problem is the gap in between. Either the gap is like this, or if I take this entire circle and move it on the inside, I want to see what is there a gap between the two circles, then they do not touch. So let me calculate the second quantity. The second quantity that you take is, the second quantity that you need to take is mn, distance mn. The distance between the centers, you have to take this. So this is distance between centers. Right. Now, what is the distance between the centers? You use the distance formula. So it's going to be -8 minus -5. So +5 all squared plus 5 minus 2 all squared. So that is 9 plus 9, because this is, wait, y2 minus y1 minus 8 minus -5. That's minus 3 squared, which is 9. And 5 minus 2, which is 3 squared, which is 9. So you're going to get 9 times 2, 3 root 2, which is equals to 4.24. Right? And 3 root 10 is 9.49. So basically, the distance between the two centers, you don't have a case like this. The distance between the two centers is smaller than the sum of the radius. So basically, what's happening here is that these circles are definitely not disjoint. It's basically intersecting. It's like this. See, I'm moving it there. Right? So now, if I take R1 plus R2, if I take the distance between the two centers, is 4.24, but if I add the radius, I'm getting 9.49. What if I try to minus the radius? Because remember, they intersect, the circles intersect, right? Circles intersect. We know that